Hello and welcome to today's IWCS webinar. Now I'm pleased to turn the webinar over to Ed Fenton, your IWCS moderator. Ed, please go ahead.
Thank you, Connie. Our IWCS webinar series event is hosted by the International Cable and Connectivity Symposium. I am Ed Fenton, a cable industry advisor working with the IWCS team. As Connie said, if you have any questions, please use the Q&A box on the bottom right of your screen to post a question anonymously. If you wish to contact the presenter or IWCS, you will be given the contact points at the end of the webinar. Please note that IWCS does not distribute the presentation slides from either our conference sessions or these webinars. However, please feel free to contact the presenter directly and they will respond individually to you. I'd like to continue today by welcoming Mabud Choudhury, Standards Manager, OFS in Georgia, USA, who will be presenting his paper on standards, technology, market and industry trends, and future direction for MMF. Mabud Choudhury is Standards Manager for OFS. He represents OFS in IEEE 802.3 Ethernet, INCITS T11 Fibre Channel and IEC standards. Previously, he was R&D engineer and manager for product development systems engineering and standards of copper, fiber, and intelligent cabling infrastructure, products and solutions for AT&T Bell Labs, Lucent, Avaya, and CommScope. He has an MS degree in mechanical engineering from Massachusetts Institute of Technology and a BS degree in mechanical engineering and in chemistry from Duke University. He holds 32 U.S. patents and has authored several papers, webinars, and IEEE Fiber Channel TIA standards contributions. Mabud, we welcome you to present at today's IWCS webinar series event.
Thank you, Ed, for that introduction, and thank you, Connie, also for the web hosting. And thank you to all the attendees for taking time from your busy schedule to attend this webinar. Hopefully you'll find it informative. I also wanted to thank IWCS for the opportunity to make this presentation. We actually presented a version of this paper at IWCS in 2017 first, and this version is an updated version from last year, as Ed was indicating. And the topic, as indicated, is standards, technology, market industry trends, and future direction of multimode fiber. I've got a couple of quotes that I always use during the presentation. My first one is that predictions are difficult, especially when it comes to the future, which is a quote I'm sure a lot of you have heard. So we've actually feel good about the predictions we've made in this paper going back to 2017. I think a lot of those trends have held, and the direction seems to be there for multimode and VCSEL links. But I think anytime you're looking at the future, you should do it with a sense of humility. Things can change dramatically and disruptively at times. So I guess with that caveat or disclaimer, I'll go on to the presentation. So let me see if I'm okay. Went the wrong direction. So the agenda for today, for the introduction, I'll be talking about the key advantages of multimode fiber and multimode VCSELs. Then a very high-level discussion about current and market and future trends in terms of data center trends, in terms of 100 and 400 gig Ethernet direction, then multimode module and cable forecasts. And a lot of the presentation will cover, which I've updated to be current, for multimode fiber standards ecosystem and update. So TIA, IEC, ISO IEC, T11 Fibre Channel, the MSAs, SWDM4 and 400 gig BiDi MSA, IEEE standards 802.3, and then a focus on next generation 100 gig PAM4, so that's 50 gigabit PAM4 VCSELs links, and possible next generation links. So in terms of key advantages for multimode fiber and VCSELs, VCSELs have been around for some time. They've historically maintained a low-cost advantage in terms of manufacturability, integration, reliability, testability, and as a low-power solution. So as data rates per lane have gone from 1 to 10 to 50 to now 100, that advantage is held. There's been over 1 billion VCSELs that have been sold, communications VCSELs. Cousin for the communications VCSEL are the 3D sensing VCSELs, in Apple is your Face ID, and those have even higher volumes and even lower cost structures. So VCSELs are a very well-established, low-cost, low-power technology. From a multimode fiber perspective, it's a larger core size than single mode, which allows for lower alignment costs and leads to lower connectivity costs. It also has a higher resilience to contamination and has higher usability. So we all know for fiber connections, you should always inspect and clean first, but that resilience to dirt does give an advantage, and that's often a failure point in networks in dealing with reliability. There's been over 14 million kilometers of laser-optimized multimode fiber that's been sold. So it's a very high-volume, reliable, interoperable solution that's well-established for many years. In terms of market trends, and this is actually from the previous Cisco Global Cloud Index data information. There's a more recent one that we'll update, but these trends have been there for a while, and I think they're really well established at this point, is that cloud traffic is growing at an exponential rate, that it's a huge progress in terms of where data processing and IT infrastructure is going. So I think that's well established. I think what's sometimes not always as well understood, or there's some misconceptions, that automatically means that we're going to the largest cloud data centers, so the hyperscale mega data centers. If you look at actually the underlying data for Cisco's information, they look at 24 companies, and some of them are actually what would be classified as large enterprise-type customers, and some of them are obviously the AWS, Microsoft Azure, Google Cloud, Alibaba, et cetera. And even within that hyperscale crowd, these are some of the leading companies on the planet. They're redefining how data centers are architected. There's not a monolithic architecture that's in place. And so not every reach is 500 meters or 2 kilometers. And what you see is that even in hyperscale data centers, and certainly in cloud data centers overall, that both single-mode and multi-mode solutions remain very viable solutions and options that customers use. The other thing to look at is this public versus private cloud. Again, public clouds are the fastest growing segment, but private clouds and the way they're implemented can vary, whether it's on premises, whether it's through co-location, or through a public cloud service provider, so an AWS Outpost, for example. These are all high growth areas. And really what's happening is that for large data centers, they're being transformed to support cloud computing. And what the biggest growth that you see is in hybrid clouds or hybrid architectures. And once again, that says that from a fiber link perspective, both multimode and single mode remain important solutions. This is a Deloro view for data center Ethernet switch ports. And again, this underscores that the strongest growths are happening with those 4 largest U.S. cloud service providers, with some of the Chinese cloud service providers. But the large enterprise private cloud remains a very strong segment of the market. And that's a segment where multimode links remains important. And as I indicated previously, even for the largest cloud service providers, multimode links are utilized. When we're looking at things like market data and trends, I think it's always important to look at multiple sources, and it's always important to continuously go back and review that data. So there's a Gartner view and sort of an Uptime Institute view that, at least in first pass, look like they're in conflict. Gartner sort of has an attention-grabbing headline that they say the data center is dead or almost dead. They're forecasting that by 2025, so in just 5 years, that 80% of traditional data centers will be decommissioned or disappear. Uptime Institute, in a study that they did in 2019, indicate that there's still a strong dependency on privately owned and operated enterprise data centers. So while at first blush they may look like in conflict, I think what's really happening is that data centers are being transformed. So if you're talking about a traditional non-cloud data center that's on premises, that's certainly a model that's diminishing. but even for on-premises data centers, certainly for co-location, and also cloud-enabled data centers, hybrid structures, things are moving in the direction of cloud computing. And how that's implemented varies quite a bit, and the solutions from a fiber perspective also vary from that regard. The next slides I have are really looking at some forecasts from Light Counting. This is an organization that I hold in very high regard. They really have some industry experts to look at this information, and if you're looking at specifically optical modules and the market segment that we tend to focus in on, they have very good information. They regularly update their forecasts, so that makes them more realistic over time. And this particular chart looks at what's happening in terms of optical modules. So this is single mode, multimode, all variants essentially. And if you look at 2019 to 2020, there's still actually quite a bit of 1 gig and 10 gig modules there. So if you talk to a lot of customers, that's what you'll find in their data centers today. What's rapidly growing is 100 gig. The expectation is by the next couple of years that'll become the dominant speed. And 400 gig starts to become deployed in larger volumes starting this year and next year. So that's essentially the forecast that Light Counting has. If we drill down from that and look at 100 gig and 400 gig, in terms of 100 gig modules, and the way the top chart breaks things out is by reach. So the second fastest growing or projected growth is 400 to 300 meters. So these are the multi-mode modules, so SR4, SR2, ESR4, SWDM4, and BiDi 100 gig modules. Again, very strong growth forecast there, as are the single mode modules. So this is not an either or, it's that both have good growth potential. Looking at the chart below that for 400 gig, and the note here is that 400 gig SR8 is actually not shown here because that's categorized as a 2 by 200 gig solution. But 400 gig SR4.2 is actually the second fastest growth module in terms of the Light Counting forecast. Again, showing the relevance for multimode, even as the speeds go up to 100 and 400 gig. And this sort of overall view from Light Counting looks at multimode versus single mode, 25 to 400 gig, all modules. So these are for long-haul applications, they're for data center applications. And again, what's there is that single mode is growing at a huge rate. It's clearly the highest growth rate. What sometimes gets masked in that process is that multimode also continues to grow. It still has a healthy growth rate. It still remains relevant in terms of the optical modules that Light Counting is forecasting over the next 4 years or so, 4 to 5 years. The bottom chart looks at a CRU projection for worldwide multimode optical cable market. And again, what you see there is a steady growth in terms of what's there. Obviously, economic events, we have COVID-19 in there. Those things can't be forecast directly, so things can go up and down. But the overall trend is for growth in those markets. I'm going to switch now to some of the standards part of this and the update there. From a TIA and IC and ISO-IC perspective, for the last few years, going back a couple of years, there's been an OM5 specification that extends basically OM4's performance from 850 to 953 nanometer wavelength from a bandwidth perspective. The IC Subcommittee 86A completed last year the Fibers and Cables document, which is 60793-2-10, and there's EMB guidance, which is informative for OM3 and OM4 fibers up to 850, between 850 and 953. So the 850 number for OM3 and OM4 is normative or required, and the 850 and 953 is required or normative for OM5. From a TIA perspective, TIA has actually been going through a process with their TIA 942 series of documents of restructuring them and basically harmonizing them and making them consistent to the IEC documents, which helps the overall global industry standards community. So from a multimode perspective, it's basically adapting 60793-2-10 2019, the one that was just published, and that in the meeting in January at TIA, all comments were resolved, and that new document, TIA 942 AAA E, will become a standard and will become published. So that lays the foundation from a fiber perspective, fiber standards perspective, going forward. In terms of fiber channel, and fiber channel actually is a major multimode application, 90% of fiber channels, which is a point-to-point network, a storage area network type solution, very high reliability, has from the IEEE equivalent slightly higher data rate as you look at each speed, and a tighter BER than some of the Ethernet requirements. IEEE published SCPI-7, which is 64 gig fiber channel that got published last November. The technical work actually had been done for some time, but it's now an official document. So that's from a lane perspective, it's similar to 50 gig type lane in Ethernet, and that's 64 gig fiber channel, and it has 70 meter reach on OM3 and 100 meter reach on OM4 and OM5. The active projects in fiber channel right now are PI-7P, which is a parallel version of that same standard. So it's a 4x64 or 256 GFC parallel. And that's progressing and expected to be published by August of this year. The other main project that's in T11 right now, T11.2, is FCPI-8, which is 128 gig serial fiber channel. So again, the equivalent of 100 gig per lane on the Ethernet side. The data rate is projected to be 112 gigabits per second for fiber channel. FCIA actually provides the MRD, which is the marketing requirements document, and it's looking for something that's backward compatible to 32 and 64 gig fiber channel, and has a target date of 2021 availability. The first contribution there actually looked at something with a 50-meter feasibility on OM5 at 940 nanometer. That can change over time, but that was the first contribution. And the initial working draft of that has been initiated. We also have SWDM solutions from an MSA perspective that have been in the market actually now since 2018. They were announced in 2017. These use 4 wavelengths, 850, 880, 910, and 940 nanometer, and give 70 meter OM3 reach, 100 meter OM4, and 150 OM5 reach. We also have BiDi solutions that's there. I didn't cover it, but there's a 100 gig BiDi that's available. That's a proprietary solution. And the 400 gig version of that is 400 gig BiDi 4.2. So that's 2 bidirectional wavelengths at basically the center wavelengths are 850 and 910. And the reach, again, is 70, 100, and 150 over OM3, OM4, and OM5 respectively. So OM5 has a reach advantage both for SWDM4 and BiDi, the multi-wavelength solutions. From an IEEE perspective, we just completed, it was last month where it became official, is P802.3cm, which is a 400 gig over multimode fiber task force project. That was the work that was done to create that standard. And it introduces 2 new PMDs. There's a 400 gig base SR 4.2, which is very similar to the 400 gig BiDi MSA that I mentioned, 2 BiDi wavelengths per fiber. It's a low-cost point-to-point switch solution, so it basically uses the SR4 or quad type paradigm, so you can go from 40 gig SR4 to 100 gig SR4 to 200 gig SR4 to now 400 gig SR4.2 on the same cabling infrastructure, which has a lot of value, especially in the large enterprise data center market. And it can be also used for shuffle and breakout. And the objectives or the goal that was achieved is 70 meters OM3, 100 meters OM4, and 150 on OM5. The other PMD is a 400 gig big base SRT, which sort of extends the previous 802.3 CD standard to 400 gig for multimode fiber, and offers the maximum flexibility in terms of shuffle applications. So you can use it as a 400 gig switch application, or a 2x200 switch, a 4x100 switch, or an 8x50 gig switch application, and of course supports breakout, and supports both a single row MPO 16 and a dual row 24 MPO. dual 12-row, which is a 24 fiber NPL. And again, that project was kicked off in 2017, and it completed in January of this year. Just in terms of who's using this, this is a view from Alibaba that they presented a couple of years ago. So in their forecast, they were already using 100 gig base SR4, and we're looking to use 400 gig base SR4.2. That's switched more to SR8 in their case. Google has always been a proponent or has utilized single mode for short reaches, 40 gig SR4, 100 gig SR4. And Zuowei Shen, who's an industry expert affiliated with Google, was one of the primary drivers behind 400 gig base SR8. And Google, in fact, is already using that SR8 as a 2x200 SR4 solution in their networks. So again, multimode gets used by a wide variety of customers and solutions, including in the largest hyperscale data centers. There's a new project that's there, switching essentially now to 100 gig per lane. So the way IEEE works is you initiate things with a call for interest, a CFI. That happened in November last year. And this is looking for a lower cost short reach optical PHY using 100 gig per second wavelengths, so essentially per lane or per wavelength. What's driving this is that SerDes or server attachment speeds are increasing from 25 to 50 to 100 gig. That's the top chart, indicates some of that progress. And it's expected that what's prevalent today, which is a top-of-rack switch architecture, will give way as we go to 100 gigs more to a middle-of-row or even end-of-row type switch architecture. So reaches up to 30 meters becomes required in that architecture, and that bottom slide, sub-slide there, shows some of that information. From a 100 gig per second perspective, a sister standard project is 802.3CK and has an objective of basically 2 meters per passive copper or direct attached copper. So the copper reaches are shrinking as the data rate goes up, and yet because of power density, there's fewer servers per rack, so your switches need to be deployed in more of a middle-of-rack type solution. There's still active optical cable, which is not directly part of IEEE structure, but it has certain disadvantages in terms of supporting breakout, in terms of supporting rapid deployment with overhead cabling. So pluggable transceivers with structured cabling, which is basically a best SR approach, has an advantage and is the basis, a key basis for this project. There's also work that's been done by the Open Data Center Committee from China, looking at their next generation data center connections, and they're also seeing multimode as a low-cost solution at 100 gig per wavelength. They believe 30 meters is reasonable for multimode links for either AOC or transceiver-based server interconnects. And they also are looking for longer multimode transceivers for switch-to-switch connectors. And in this case, longer is better, so 70 or 100, but 50 meters would serve a lot of their applications. Just quickly, in terms of the CFI, there was a couple of presentations. The way IEEE works is that it's individual participants, it's not company participants. So individual experts affiliated with Broadcom from their VCSEL side and individuals affiliated with II-VI, which is formerly Finisar, indicated technical feasibility of 50-meter OM4 links using 850. In the case of II-VI, they also indicated 940 or 850 as the wavelength, and 50 meters being possible on OM4 or OM5. This chart is in the paper, and I request people to look at it. Gives sort of the background from a literature perspective, academic and otherwise, of how 100 gig VCSELs have been shown to be technically feasible. The CFI, which was again in November, had very wide industry support. So a lot of even end users or customers, experts affiliated with Wells Fargo and Microsoft and Alibaba, for example, and a lot of the other industry experts supported this project. Starting off, the next phase becomes a study group, and IEEE basically unanimously supported the formation of a new study group. So that study group, actually, then this brings us up to last month, met in Geneva And the way IEEE works is the study group produces a project authorization request form. And the thing I want to emphasize here is that this project actually, the scope includes both multimode and single mode. So either type of PMD or PHY is possible, depending on what contributions are brought and what consensus achieved as standard. It then moves on to criteria for standards development and sets objectives. So the key objectives so far have been all multimode, essentially 100 gig over one pair, up to 50 meters, up to at least 50 meters, 200 gig over two pairs, and 400 gig over four pairs, all with a reach of 500 meters. So those are the objectives. Those aren't the solutions. That would be the goal for the force, and the goal would be to form a new task force. And the task force that's being targeted, we're hoping that we'll get those approvals in March, is P8062.3dB. And just for those of us who are in standards, that dB nomenclature was a big deal, because if you're an electrical person or an optical person, it's a nice designation. It's just sequentially the one we got, but it's a cool designation for those of us who spend too much of our lives in standards. So going on to the next thing. In terms of Ethernet modules, this shows again a range of Ethernet multimode modules for speed greater than 100 gig, be it MSA, proprietary, or standard. So again, lots of activity for higher speeds for multimode that's either in place, that's commercially available, in standards that were just published and being deployed, which was 802.3cm, and is being targeted in this new standard, which is right now 100 gig SR study group, the one that I just covered in the previous slide. And it forms the foundation. Those last two rules indicate that it's possible as 800 gig and 1.6 terabyte MAC rates are established. The foundation is being laid with 100 gig VCSELs for multimode VCSEL link solutions well into the future. But this next slide actually captures some of that possibility in terms of what's there. The top half of that is, again, covering the notion that you could have 100 gig SR, 400 gig SR4, and a 200 gig SR2. So those are all possible, and the modules to support that. If BiDi is used, then you can essentially get to 800 and 1.8 gig and 1.6 terabyte on 4 pairs and 8 pairs. And if SWDM4's technology is used, you can get to 800 gig on 2 pairs and 1.6 terabyte on 4 pairs. So again, not all of these PMs will be adopted. Depends what support is there, what the relative costs, what the advantages are. But it shows the potential for multi-code and VCSEL links well into the future. So I won't cover all of these, but the summary here is that what I covered is that there's some key enduring advantages. The largest hyperscale markets are deploying them. There's one of them in large enterprise markets, which is still around for VCSEL multimode links. The paper covers it. I didn't cover it here. There's other high-growth markets. Edge co-location and automotive is actually an area where multimode becomes viable, and there's an active standard there. There's a standards ecosystem that supports it. 802.3 has multiple standards, both now and actively and just recently published, as does Fiber Channel and the MSA group. 100 gig and 400 gig are being deployed actively right now. The technologies there for 50 gig, basically 25 gigabaud PAM4 VCSELs are well established, and we're starting on 100 gig, 50 gig PAM4 VCSELs also. So the next generation is there, and OM5 is positioned and optimized to take advantage of BiDi and SWDM4 with industry standards and 150-meter reach. So my last quote quickly is that Mark Twain, Samuel Clemens quote that the rumors or reports of my death have been greatly exaggerated. Multimode sometimes feels that way if you work in that area, but multimode actually has a very strong future based on the things that I just covered. So thank you for your time.
And thank you, Mabud. And at this time, we will take as many questions from our attendees as time permits. And I will remind participants to use the Q&A box on the bottom right of your screen to post a question anonymously. And you may contact the presenter after this presentation. I will start with the first question, which is, multimode fiber technology continues to have relevance and value for data centers. what other technology innovations being developed in terms of single-mode fiber might further replace MMF designs in the future?
So I think most broadly it's silicon photonics, and whether it's been PSM4, which has, I think, had a lot of success, but DR-type technologies are there, as is CWDM4 and CWDM Lite. So I think those things continue to have advances, tend to continue to have lower cost structures. As I indicated before, it's hard to predict if there'll be a major announcement at OFC next month or a year from now. But single mode offers a lot of advantages and solutions that are there. But again, historically, for the shortest reaches, and that gets redefined as the speed keeps advancing, multimode still holds that cost advantage to date. But this latest IEEE standard, as I indicated, will entertain contributions and look for consensus, whether it's multimode or single mode, in looking at these next-generation server attachments and next-generation very short reach switch-to-switch attachments.
Okay, thank you. Next question. Will MMF continue to be predominant within both enterprise and service provider hyperscale data centers for 200G and 400G solutions?
Yes, I think, again, the charts from light counting indicate that there will be a clear presence. It tends to be in large enterprise data centers, which typically have reaches of 100 meters or less, or 150 meters less. So an OM5 or an OM4 solution makes quite a bit of sense there in terms of supporting multiple generations of SR-type technology, SR4-type technology. In terms of hyperscale, as I indicated, it depends on the provider. Again, these are tremendous companies with some of the smartest people on the planet working on them, lots of resources. They tend to redefine their architectures. There is not a monolithic architecture. So in certain applications for certain reaches, the shortest reaches, as in the case of Google, for example, they're deploying 400 gig SR8 as a 2x200 as the next application speed for reaches up to 70 meters.
Okay, thank you. Next question. Do different regions of the world prefer either an SMF or MMF solution? And if so, what are the drivers that might sway the design selections?
Yeah, great question. And again, I'll actually reference some of the contributions that were made in IEEE. So the Chinese market, even for the hyperscale companies, the data centers tend to be physically smaller, and I think that's tied to them being more in urban centers and not as much in suburban or rural centers as is the case for some of the North American service providers. So they're architected to have shorter reaches. But again, even for the North Americans, as I just indicated, it depends on the system. So there are regional differences where certain solutions make more sense, and it really has to do with, do the shorter reaches continue to be important or not? But again, this notion of server attachment speeds going up to 100 gig means something that's been typically passive copper, direct attached copper, or AOC becomes potentially a multimode type solution.
Okay, next question. I believe this is a clarification of a data number. The question is simply 500M or 50M.
I'm trying to remember the reference here. So
okay, I'm attempting to field the question, but it has. The questioner says it has to do with slide 24.
Slide 24. Let's go to 24.
Right.
Okay.
And the question is 500M or 50M.
So it's 50 meters is the reach that's being talked about here. So the objectives are set for 100, 200, and 400 over 1 pair, 2 pair, 4 pair, multimode, all with up to at least, that's an IEEE kind of terminology, basically less than or equal to 50 meters reach.
Great. Perfect. I hope that clarifies.
Yeah, and the question's relevant in the sense that DR, which is a single mode variant, so DR, 100 gig DR already exists, as does 400 gig DR4. Those are 500-meter reach solution. So the single-mode reach does have longer reach, as one would expect.
Great. Thank you. Thank you for the clarification. At this point, I see no further questions. So I would like to thank you, Mabud, for presenting this very interesting and important topic today. Please note the contact points being shown should you wish to contact Mabud after today's event. Each of these IWCS webinar series presentation events are recorded and will be archived on the IWCS.org website. It normally takes up to 2 weeks for these to be posted. The IWCS webinar series will conduct presentation events on a monthly basis. Webinar events will take place on the third Friday of each month at 10:30 a.m. Eastern USA time. Our next scheduled webinar event will be on Friday, March 20th at 10:30 a.m. Eastern USA time. Each of you will be receiving an announcement for the event a few weeks prior. Please feel free to share our announcements with your colleagues so that they can join in and register as well. For over 68 years, the IWCS International Cable and Connectivity Symposium has been the recognized leader showcasing new technologies in cable and connectivity products, processes, and applications. Our next 69th annual conference will take place on Sunday, October 11th through Wednesday, October 14th, 2020 at the Rhode Island Convention Center in Providence, Rhode Island, USA. In addition, please note that our 2020 UL and IWCS China conference in March was unfortunately canceled due to the coronavirus crisis. The next UL and IWCS China Cable and Connectivity Symposium will take place on Tuesday, March 23rd through Thursday, March 25th, 2021 at the Marriott Hotel City Center in Shanghai, China. Please visit our website at IWCS.org for more event details. In just a moment, you will see a brief survey so that you can provide us your feedback and comments on today's event so that we can further improve this webinar series for you. Thank you for participating, and this concludes today's event.